Differentiation Review's first 10 videos were all about solving derivatives, and I think that we beat it to death, but it was excellent practice, and you definitely need to know how to do that stuff. But now we have to take what we've done and prove that we're masters with and put it into a word problem. So here is number 1. The angle of elevation of the sun is decreasing. So we're going to need a sun. I'm going to draw my little sun here like this. At a rate of 0.25 radians per hour. So let's say, here's my theta. They're saying d theta dt. How do I know that? Because it's radians per hour. That's a theta and a time. So it's theta per time. Equals 0.25. We should say negative 0.25 because the sun is descending and theta is usually going this direction. So we just need to keep the convention to make it accurate, but probably won't be a problem. Radians per hour. And they say, how fast is the shadow cast by a 400-foot tall building? So let's draw a building. Here's my building. And it's got a height. We'll write over here that its height is 400. And it casts a shadow like this, doesn't it? And just so that we don't use an X and Y, we're going to call this S instead. And they say, how fast is the shadow cast by this building increasing? Because as the sun gets here, the shadow is going to be wider. Yeah. When the angle of elevation of the sun is pi over 6. So we learn that theta has a value. And they're asking you for what? How fast is the shadow size increasing? So that is, what's that, a ds dt? Change in shadow over change in time. That's what they want. Okay, so we have a few values here. How do we put them together? We have a theta, we have an opposite, and we have an adjacent. So I'm going to go with that. Opposite and adjacent, that's tangent. So I'm going to say tangent of theta. Got to learn how to crawl. Equals opposite, which is h, over adjacent, which is s. So far, so good. I don't think we've made any mistakes, but we're going to end up wanting to solve the derivative for s. So let's flip this around a little bit, and we'll say s equals h over tangent of theta. And that's the same as dividing by the reciprocal, so we'll say it's h times cosine theta over sine theta, otherwise known as cotangent. So now it's not a division, really. It's a multiplication. And if I want to remember how to do the derivative here, because I want a ds dt, well, the h is just a value, so that doesn't need to be part of it. But this is a quotient rule, unless you remember the derivative of cotangent, which I never do. You might think it's negative cosecant squared, but it doesn't matter what it is. If we can find it, we don't need to memorize it. So our u is going to be cosine. Our u prime is going to be negative sine. That much is obvious. V is going to be sine. And v prime is going to be cosine. Theta, theta, theta. All right. So u prime v, that's going to be negative sine times sine minus v prime, which is cosine, times cosine for u, over v squared is sine squared. So this is on top. If you factor the minus out, you're going to get a negative 1 over sine of theta squared. I hate using cotangents and secants and cosecants. Everything should be in sine and cosine. That's the easiest derivatives, but more importantly, they're the ones that you're going to know as your trig identities, because what do we have to do next? Oh my, I almost made a mistake. Did you catch the mistake? I did all this work, but I took ds dt. And this is taking the derivative of theta, not t, which means that you have to chain rule d theta dt out here, like that. That could have been a big mistake. So remember that chain rule. If you're not taking it with respect to theta, then you have to chain rule. Okay. And we know that too. They already told us that value. So that makes sense why that exists now. Now I think we just plug it in because they asked us specifically how fast the shadow of the building is increasing. They didn't ask us to find the derivative. They asked us to find a value. So h is going to be 400, so we'll get negative 400 here. And the angle is pi over 6. So what's the sine of pi over 6? Sine goes like, that's going to be 1/2. The smallest one there is 1/2. So it's going to be over 1/2 squared times d theta dt is negative 1/4. Like that. So this is going to be 1/4 and this is going to be 4. I think those cancel each other right out. 1/4 and 4 cancel each other right out, don't they? So we're going to get 400 feet per hour. And that's how fast the shadow of our building is increasing in this direction. But they didn't ask for direction. They just asked how much is it increasing as the sun goes down, like this. So at that exact moment, that's the answer to problem number 1. Let's rock some word problems, huh?